Hello and welcome. As we meet here on MS Excel, we'll try to solve exponential smoothing and exponential smoothing including trends using MS Excel. Now, as a student you could solve it using paper, pencil and calculator, but we'll see how changing alpha from 0.7 to 0.8 to 0.9 or 0.1 or 0.2 or 0 or 1, whatever value, how changing values of alpha affects the final forecast, and what is the final effect on the errors in my forecast. Now ideally my forecast should be such that they are very close to my actual demand. So we'll see how changing alpha reduces the error. So for the sake, we are taking the same data set that we have taken in previous lectures for different methods that we have solved up till this point. So we'll keep the same data set and we'll make a column of forecast over here. And for the purpose, the alpha that we are making use of is 0.7. So I'll put up a table over here, and then what for first period the forecast is given. In exponential smoothing we'll be studying exponential smoothing method. Exponential smoothing method. So we'll see exponential smoothing method. Yes. So we'll see the exponential smoothing method. For the purpose, forecast is also given always for the first period. First period forecast is necessary because the formula is such that we need first period forecast. The formula is forecast using exponential smoothing method is given over here. We can see here is the formula, and now I'll try to write the formula for exponential smoothing using Excel. So the formula is like alpha, here is our alpha, multiplied by actual demand for t minus 1 plus 1 minus alpha. So I'll make 1 minus alpha multiplied to forecast for demand for t minus 1. So here is our formula. What have we done? Alpha into previous actual demand, D5 is previous actual demand, plus 1 minus alpha into forecast, previous forecast. Here is our formula. Alpha, previous demand, 1 minus alpha, previous forecast. So this is our formula, and we get our forecast here. Now if I copy this forecast to everywhere, this is the forecast for each period. Third period forecast is 11.4, 13.22 and so on. Right? Now, first let us try exponential smoothing method including trends, and then we'll talk about how changing alpha affects the exponential smoothing method, how changing alpha affects the exponential smoothing including trend method. So first let me copy this data set to a new table. Again I'll be having an alpha. Let us continue with same alpha, but this time we'll also be having a beta value. Beta is equal to, let us say we are taking beta as 0.8. Right? Then what do we have over here? We'll have a column of forecast, because each time we'll be preparing a forecast. Then there will be a column of trend. Then finally there will be a column of FIT, forecast including trend. And now let us again make a table over here, and what I'll do is I'll paint them bold and red, that these are the values that we have forecasted. Everything else, everything in black was given in the question, and these are the values that we have forecasted. Same we'll do over here also, bold and these forecast and trend values will be given. We are taking 10 and 10. I'll paint them same. So this is all that will be given in the question when you are trying to solve it using exponential smoothing using, or rather including trends. So when I use this method, all these informations will already be given to you. I'll center align it to make it look beautiful. Fine. Now we need to write a formula for these. What is the formula for forecast? Here we have our formula for forecast, FT. The formula for forecast is alpha. We'll put it is equal to alpha actuals of t minus 1. Actuals of t minus 1 are multiplied by actuals of t minus 1 plus 1 minus alpha, let me close the bracket, and forecast of t minus 1 plus trend of t minus 1. Let me open the bracket, forecast of t minus 1 plus trend of t minus 1. Let them make a correction. So we get 13. Fine. And as for trend, the formula is beta is equal to beta multiplied to difference in present forecast and previous forecast. So that will be this minus previous forecast plus 1 minus beta, 1 minus beta, and then trend of t minus 1, that is previous trend, multiplied to previous trend. Here we get our trend also. Then what is FIT? Forecast for period T is simply a summation of trend of T plus forecast of T. So I'll put it as is equal to this plus this. Here are our forecasts. Now to find out remaining all values, what I'll do is I'll simply stretch this, and these are the values that we get. Perfect. Fine. Now if we were solving it using exponential smoothing, we made use of alpha as 7 and these were the forecast. If we are solving it using exponential smoothing including trends, this is my alpha and this is my beta. I'm making use of alpha as 0.7, beta of 0.8. Now let us check this data for errors. Now I have forecasted this. Now my forecast is that for first period it will be 10, it was given. Second period I forecasted 10, 11.4 and so on. But the real data was this. So was there any error or not? Was I forecasting correctly? I should be able to check. Same is over here. I used FIT, exponential smoothing including trends. These were my forecasts. Are they close enough to the actual values? Or are they far off? So for that, let us make use of MAD. So for MAD, we'll calculate deviations for mean absolute deviation. Deviations for mean absolute deviation. We'll find out. Let me put it over here also. And let us make a table also for this. We'll find out deviations and then we'll see how much was I deviating. Fine. These were my forecasts. This was not exactly my forecast. This was already given in the question. I'll make use of these forecasts. Now, what is deviation? Deviation is simply demand minus forecast. So this will be equal to demand minus forecast. Now, if I copy it to everywhere, these are my deviations. Majority of the times I was falling short. 40 I forecasted 24. I fell short by 16. 23 I forecasted 26. This time I over forecasted it by 3. So these are for this. Over here it will be actuals minus my forecast. Actual was 12, my forecast was 17. I copy it Actual was 14, my forecast was almost 15. Actual was 40, my forecast was 28. So there was a loss of 28. So these are my MADs. Now mean absolute deviation. Mean absolute deviation is mean of these deviations. So what can I do? I can do is equal to average of these values. So MAD in this case is MAD is equal to MAD in first case is this value. All these values are found out. So I'll make them again in red. This is my MAD. What is the MAD in second case? Now see, we are doing two questions here. This is our first question using exponential smoothing method, and this is our second question using exponential smoothing including trends. Here we'll make it once again. So this is my MAD in this case, second case. Right? I'll make it bold. And what will be the MAD? It will be equal to average of all the deviations. These are my deviations. Acha, we were taking, sorry, just a second. We were taking absolute deviations. So this -3 shouldn't have been there. We were taking absolute deviations. So absolute deviations come from ABS. Sorry, this was my mistake. I took deviations instead of taking absolute deviations because I wrote here deviations, so I took deviations. If I take absolute deviations, this -3.1 will become +3.1. This has become +3.1. Fine. And then we can have our MAD is this time 7. Here also we need to take absolute deviations. I took deviations instead of absolute deviations. So this -0.996 will become 0.996. This -12 will become +12. And now I can have my MAD for second case. It will be average of all these numbers. So it is 7.31. And let me make all these values red and bold because we have found out these values. Now, my error in this first case is 7, almost 7 mean absolute deviation. So my average deviation, my average error is 7. Now if you remember our previous lectures, we talked that for highly dynamic environments are where values are changing every second day, every second period. They are going to 20, 50, then they are coming to 13, then they are going to 80, then they are coming down to 40. They are changing all the time and changing by huge distances. Those are dynamic times. In such cases, alpha should be taken as very high. When values are changing a lot, take a very high alpha. And when values are changing very less, take a very low alpha. Extremes were 0 and 1. Let me see what happens when I take it as 0. When I take it as 0, my MAD becomes 13. When I take it as 1, my MAD comes down to 7.33. So which one is better? 0 or 1? Definitely 1 is better. But yes, we generally try to avoid 0 and 1 because they reduce the exponential smoothing method to novice method, as we saw in previous lectures where we talked about exponential smoothing for the first time. So 0 and 1 should be avoided. Rather, what we can do is we can take a very high value as high as 0.8 or 0.9 or something like that. So here we see that in fact 0.8 is giving me better values. 0.9 is not giving me such better values. 0.8 was best. 0.7 is still lower. 0.6 almost same. 0.5 increasing. So this is how, being a production manager, you can tell me that what alpha suits me. I come to you with my data. I come to you with my data for 7 periods and ask you to suggest me what alpha should I make use of, and you tell me that alpha of 0.7 or 0.8 is very good for me because this is giving me least absolute deviation. As a student, you need not worry about changing the alphas. As a student, alpha will be given, first forecast will be given, you can find out all these values. You can find out all these values, this is your answer. If they ask for errors, you can find out these values and take average of these values. So as a student, things are very simple. As a student, this is your question using exponential smoothing method. As a student, this is your question where you have found out values using exponential smoothing method and also found out mean absolute deviation. As a student, this is done. But as a manager, this is how you can check. What happens if I make it 0.2? If I make it 0.2, the mean absolute deviation goes up to 10. So 0.2 is not a very good alpha for my business, for my data. So I can always make use of 0.8. And once I know that 0.8 is my industry or my product alpha, from here on I can go on making use of 0.8 or rather 0.7, which we started with. So once you know your alpha, from now on when you ask me to forecast it for 8th period, I'll make use of 0.7 because now I know that this is my best alpha. Now this was a discussion about exponential smoothing method. We are also talking about exponential smoothing including trends. So these are my MEDs. Now what happens for alpha? Alpha, same rule applies over here also. If you are living in very dynamic environments, make use of a high alpha. And if you are living in stable environments, make use of a smaller alpha. We'll see what happens. If I make it 0, my MAD goes to 32. If I make it 1, my MAD comes down to 7.8214. So definitely 0 or lower alpha is not suggested because it is giving me huge error. On average error of 32, while 1 is giving me an average deviation of 7.8. So definitely 1 is good, but again on that pretext that we should not make use of 0 and 1, we make use of a 0.7. Why are we not using 0 and 1? Because it reduces it to novice method. Right now it might be looking good, 0 and 1, but in longer run, in unpredictable environments, 0 and 1 might lead you into problems. So it is better if you feel like taking 0, don't take 0, rather take 0.2, 0.3. If you feel like taking 1, don't take 1, rather take 0.7, 0.8, 0.9. So we'll continue with 0.7 because last time also we checked 0.7 was a good alpha for this data set. What about beta? If you see a very steep trend in your data, steep trend is having values like, I'll put some values over here, having values like 12, 16, 20, 45, 98, 189, 687. Now this is very steep. Values are increasing at a very fast rate. They started slowly, but next jump was 25, next jump was almost 50, next jump was 100, next jump was 500. So this is very steep. If your data is such, you should take a very high beta. But if your data is such, like we see over here, if your data is of this kind, what is happening? That yes, there is a trend. Definitely it is increasing 12, 16, 20, 22, 24, 25. Of course, there was a drop, but by and large, there is a trend of increase. But this trend is very slow. It is not steep. In such cases, you should make use of small beta. Now, let me see if my trend is steep or normal. We start with beta 0. Beta 0 gives me a MAD of 8.57. Beta 1 gives me a MAD of 7.47. So it looks like there is a trend, and the trend is looking like, okay, it is big. But then again, instead of 1, we'll make use of 0.8. And we see that it is in fact getting me a better results. 1 is giving me 7.47 and 0.8 is getting me better results. So this is how you can check your alpha and beta also. How do I decide for alpha and beta? This is how you decide for alpha and beta. As a student, you need not worry about anything. As a student, this is your final question. These are your values that you have determined for exponential smoothing including trends. And if the question was find the forecast using exponential smoothing including trends, and then also find out mean absolute deviation. So this will be your solution, and this is your mean absolute deviation. So this was it, where we tested how we can change alphas, betas what can be different values of alpha and beta which are giving me minimum error. This is how we can check how error is being reduced. This is the power of Excel. Generally, we do not do these calculations with hand on pen on paper. We do these kind of calculations using Excel. So this was it for our today's discussion. Hope it clears some doubts. If still there are some doubts, you can leave them in comment box. And of course, subscribe to the Telegram channel that we are flashing in the top right corner, and also those links are available in the description box. So follow those Telegram channels for latest updates related to production operation management. You can leave your requests, your queries, your doubts in comments on YouTube, and then we'll take them up and we'll update in Telegram channel. So thanks for watching. Bye bye. Take care.